Since the dawn of humanity, human beings have overcome all types of obstacles. This is all thanks to the ability of our brains to change itself in response to its environment, like this piece of plastic in response to my hands, called neuroplasticity. But what do these changes to our brain look like? These changes occur in synapses, the gaps between neurons, either becoming stronger or weaker in the processes of short and long-term potentiation or depression. Now, in short-term potentiation or depression, the release of neurotransmitters in the neuron is increased or depleted respectively when fired upon. It often occurs when you have to adapt to your environment to get through a situation. Long-term potentiation or depression initiates a long-term change in the brain and in the structure of the synapse. It forms a new habit, like learning to dance. Neurons communicate with each other via electric pulses, or action potentials, similar to wires. Once reaching the end of the neuron, they trigger the release of neurotransmitters into the synapse, which are received by receptors on the adjacent neuron. These neurotransmitters tell the adjacent neuron what to let into the cell, which then could incite another action potential. In a common example of LTP or LTD, when the action potential triggers the release of the neurotransmitter glutamate into the synapse, it binds to the receptors AMPA and NMDA. Once unlocked, the AMPA door allows sodium into the cell body. Unfortunately, the NMDA receptor is still blocked by a magnesium ion. However, once enough positively charged sodium ions have entered into polarized the cell body, only then is the magnesium ion lock thrust out of the NMDA channel. This allows an inflow of calcium ions, causing another action potential if strong enough. Depending on the strength of the first neuron's action potential, more or less sodium enters through the AMPA receptors, causing the cell to either attain AMPA, strengthening the neuron, or losing AMPA and weakening it. Every learning experience can be split between two subsets. Experience-expectant learning is necessary to the development of an individual, occurring during critical stages such as infancy. These include learning to walk, speak, or eat. During such formative years, it is vital that children encounter a diverse and stimulating environment. The more experiences a child has, the more connections are formed, causing a greater aptitude towards an ability related to the experience. As they get older, their connections are pruned, becoming more specialized. Conversely, experience-dependent learning, while often very useful, is not vital to development, such as catching a ball. Neuroplasticity can be utilized for many medical purposes. Cognitive behavioral therapy can help those with obsessive-compulsive disorders learn to manage their obsessions. People can relearn to walk after trauma through practice and forced use therapy, in which forced use of the affected part of the body reestablishes its ability. Regular exercise, good sleep, eating foods high in omega-3 fatty acids, and continuing to challenge your brain leads to higher levels of neuroplasticity. You can form or break habits or increase brain function, depending, of course, on many factors, such as your level of commitment or mindset, taking on average 66 days to form this new habit. Albert Einstein once stated that education is not the learning of facts, but the training of the mind to think. Your whole life is an education, and the entire universe your classroom. Neuroplasticity is a superpower in the sense that you can attain mastery of self. You can positively learn from every experience, all thanks to WaCHOW! Brain power.